View serializability is another definition of serializability that has fewer false negatives than conflict serializability. In view serializability, we'll say that schedules S1 and S2 are view equivalent if they have the same initial reads. So for example, if Ti reads an initial value of some variable a in schedule 1, then Ti also reads that same value, the initial value, of a in schedule 2. As well as the same dependent reads. So if Ti reads a value of a written by Tj in S1, then Ti will also read that same value of a written by Tj in S2. And then finally, the same winning writes occur. So if Ti writes the final value of a in S1, then Ti also writes the final value of a in S2. And you should be convinced by these rules that this is a test for serializability. The reads are the same, and they influence the writes, and the same writes are done at the end. And so the outcome of the database should be exactly the same in S1 and S2. And when we think about this, if you sort of spend time thinking about this carefully, you'll see that view serializability allows all conflict serializable schedules, as well as handling what we call blind writes, which are writes to variables that aren't preceded by reads. So let's look at two example schedules down below. On the left-hand side, we clearly have a conflict. We have a write in T1 and a write in T2 to the same variable a. And in the schedule on the right, that conflict is clearly ordered in a different way, right? The write to a by T2 happens after the write to a in T1. But in both schedules, T3 is the winning write. It doesn't read anything. It simply writes a value to a. Maybe it writes 5, okay? And that 5 is not dependent on anything that T1 or T2 did. So the writes that T1 and T2 make to a don't really matter, and we can ignore them in the schedule. Okay? So these blind writes basically allow us to ignore conflicting orders of writes between different schedules and just focus on the final writes. And when they're blind writes, that all they depend on is themselves. Okay? So view serializability is a lot like conflict serializability, but it accounts in this case for blind writes. So some notes on the definitions we've seen so far. View serializability allows some more schedules than conflict serializability. It has fewer false negatives, but it's difficult to enforce efficiently. So we'll tend to focus on conflict serializability. Neither view nor conflict serializability allows all schedules that are actually serializable. They're conservative tests, and they're conservative in the sense that they don't understand the meaning of the operations or the data. So it's possible that there's a conflict between two transactions, but that conflict doesn't matter, okay? And the only way you'd know that is to know what's being read and what's being written. And it's really hard to tell that without application information. So conflict serializability is what gets used out in the field. It can be enforced efficiently by building a conflict graph and checking it for cycles. To allow more concurrency, actually, some systems allow special cases to be tested for. So there's an example you might want to read about on the web called escrow transactions that allows even more concurrency than conflict serializability, exactly because it starts to understand a bit about the meanings of the operations on the data. Okay, so as we learn more about the operations on the data, we can allow for more concurrency, but that makes it more complicated to use the database system. In general, conflict serializability is what you should learn and learn how to implement from these lectures.